All right, good evening. Woo! Well, thank you guys so much for having me. My name is Raza. I'm one of the co-founders and CEO of Humanloop, and I'm going to be sharing tonight just some of the lessons we've learned, best practices and pitfalls from working with a lot of teams who've been deploying AI applications in productions built with LLMs, or in production built with LLMs. So maybe just a little bit about who I am and why I have any right to tell you anything about this at all, and sort of you can decide how much to sort of pay attention to that. So for the last few years, I've been the CEO of Humanloop, as I said, and I'll talk about sort of what Humanloop does in a moment. And then before that, I did a PhD in deep learning at UCL in the UK, and I worked at Google for a little bit. So I've been both a sort of researcher and practitioner of machine learning, and then also helping people build products. And we've had the privilege, we were really early to this space, so we were sort of comfortably the first LLM ops platform. And as a result, we kind of had the privilege of, one, working with some of the earliest adopters of the technology, but also sort of seeing the evolution over the last couple of years and seeing both kind of things that have worked and haven't worked. And some of the companies we worked with are on this slide, but I think we can sort of move past quickly. The first big thing that I want to kind of communicate, though, and I think this doesn't necessarily need to be said anymore, we're like well into the stage now that generative AI is like actually producing real revenue even outside of coding. So there's like a small number of like these coding startups that have done extremely well, and I think there was some skepticism for a long time as to whether or not people were actually making money with this. And so like we see that within our customers this is true. And so I've got sort of a quote from one of our customers, Filevine, who are in the legal tech space. And interesting, they were a fairly mature company when they started shipping AI features and products. And since they started, their AI revenue now outstrips their traditional SaaS revenue, even though that they were, a Series C-ish or D-ish company at this time that they started doing that. And they're not at all exceptional sort of amongst our customers. So we are like well past the stage of people just tinkering and experimenting, and people are actually really making some money with this now. So I want to talk through like best practices, tips for building teams and things like that. But before I do that, I just want to get ourselves grounded in like what I mean by an LLM app. Maybe talk about one example, get ourselves on the same page, and then jump into that. And so when we think of LLM applications, I sort of think of them as composed of like the core AI block and then traditional software logic around it that we're all kind of familiar with. And the core AI block has a base model, so that's the OpenAI, ChatGPT, your Anthropic, some sort of open source fine-tuned model. It then has some set of natural language instructions that are usually some fixed template that has places that are going to be populated in production or at inference time. So sort of a templated structure, and that templated structure has a huge impact on the performance of the system. And then some data selection strategy for how you're going to populate that. And ultimately then also the models are augmented with the ability to call APIs or even other LLM blocks, so tools. And the way it works is just it's some DSL, so the LLM spits out a string, you parse the string, you call the appropriate function, you return the result. And then these blocks are composed, they can be in a loop, and then you call it an agent. They can be changed together. And increasingly, actually, it really is not that much more complicated than this block, because as the models get smarter and smarter, a lot of the scaffolding that we sort of have put around it, less and less of it is necessary, or it's sort of more just to orchestrate the agents themselves. And so, a concrete example of this, the OG LLM app, the first one that I think sort of had real revenue and real traction was GitHub Copilot. And so GitHub Copilot sort of perfectly fits this template. There's a small fine-tuned model. I don't know if this is still true in terms of the size of the model, but it started off with a 12 billion parameter model. And then the way it would work is that they would take the text from behind your cursor, they would look at the files you'd recently touched, look at sort of similarity between that, had some other heuristics for how they would populate the context, and then they would make a prediction as to what would come next. And in addition to sort of having that structure that we just described, the other thing that I think they did that sort of set the foundation for what everyone who succeeded has done since then is they made really good evaluation a sort of foundation to making this application work well. And I'll talk about that more in a little bit. And then they kind of regularly fine tune on the data that they're getting from this evaluation. But hopefully that gives us some sense of like, okay, what is the anatomy of the thing we're talking about? And this rough structure, like one of the things that's amazing about these AI applications and LLMs is that the rough structure and the components are the same across many different applications and verticals, right? This can be the legal coding assistant, it can be the meeting summarizer, it can be your coding assistant. And really what's changing is the data selection strategy, the tools you're exposing to the model, and the prompts. But the code is actually remarkably similar in lots of cases. Okay, so what have we seen that like really works well for the teams that have succeeded and gone on to produce, revenue-generating, successful, loved products? So I really like this quote from Colonel Boyd of OODA loop fame. Apparently, he used to sort of shout this at the Pentagon, which was people, ideas, machines in that order. And I roughly think if you're like trying to build a new AI product and staff it right, then I also think this is sort of like roughly the right order in which to think about things. Like, what is the makeup of the team that I need? And I think that's really different actually to both to traditional AI products, so like the machine learning products that came before. And then sort of the ideas here, I think, is actually like getting your evaluation criteria really clear. So the evals for an LLM application kind of are the spec. And AI development is very highly iterative. So it's not that you can sit down and sort of say up front exactly what your app is going to look like. As I said, the components are kind of largely the same. What you typically do is you build an end-to-end app as quickly as you can. You sort of get some signs of life, and then you iterate on all of the components to make it good enough. And so if you're iterating very quickly, you need to have some measure of how good is the thing that I'm working with. Otherwise, you're going to be making lots of changes, and you don't know whether you're actually improving things. So we'll go into a lot more detail on that, but I think evaluation is the second most important thing. And then finally, if you've got those things right, then the tooling you have around it and the way you build it, and obviously I run an AI tooling company, so I would say that, but I do think it's true. But I think it's it's third after getting these first two things right. So maybe we can talk about the team a little bit and the makeups that we've seen succeed and in some of the organizations. So the first thing I would say is that you don't need a lot of specialist AI expertise. So if you were building an AI product 4 years ago, 3 years ago even, then you probably would want like a lot of people with backgrounds like me who are either data scientists, who had studied machine learning, had done research, understood how to do that. You really need a lot less of that now. Because in some senses, there's people like either side of the API line, right? Like a lot of these applications are being built on top of third-party models that are served via API. And the way that you're customizing them isn't by fine-tuning or training the models that much. It's by prompting or orchestrating agents, in which case actually having deep machine learning expertise isn't that useful. And the type of sort of person that we've seen be particularly successful and the core person we see in these teams is typically someone who's closer to a full stack engineer and is very product minded and also is using the technology themselves a lot. So one of the challenges with building with LLMs today is that the frontier of capabilities is very spiky. I think there was this lovely quote from Nat Friedman where he described it as sort of alternating between spooky and kooky. Sometimes the models will do things that you're surprised that they're capable of, and then like just once in a while they'll fail in a way that is also surprising. And having an intuition for where the current frontier is, because it's very fast moving, it's hard to do unless you're just actually playing with these things a lot. And so people who are, I think sort of Sean Wang Swix sort of is trying to coin the AI engineer term. I'm not sure whether it's sort of clearly defined yet, but a generalist full stack engineer is often better than a machine learning engineer and probably makes up the majority of your team, or a product engineer. And then the people who I think are most overlooked but are actually like genuinely very critical to success are the domain experts. And in a moment, I'll go through a few company examples and talk about like, what the role of the domain expert was in each case. But essentially, the people who are actually writing the prompts and giving the instructions to the model that end up in your code base have a very big impact. And they're also a big part of setting the evaluation criteria. And I think that that's often overlooked. And then finally, you do want some people with some machine learning or data science expertise, but mainly just to help you set up the evals and the test data sets correctly so that you are not shooting yourself in the foot. You're not training on the test set and things like that. So some statistical literacy is helpful, but like it's 90% not and 10%, like one person on the team can easily do that. So maybe like to give some concrete examples. So some of these are customers, some of them are just sort of people I've spoken to a lot about building their application. But if you're Ironclad or Filevine, at Filevine it's the lawyers or like legal professionals who are writing a lot of the prompts, and so they're sitting in a in a UI that does prompt editing in Humanloop in this case, and spending hours like iterating on them, changing them, looking at evals, tweaking the tool definitions. It's not the engineers doing that because the engineers don't have the domain expertise to know how to instruct the model. And without those legal experts to kind of like pass that information in about not about the outcome, but like about what you want the model to do, like what does good even look like. And they're also involved in in helping create the evaluation sets and in doing some of the evaluation as well. And I'll talk about sort of how to do evaluation. Or at Duolingo, it's language learning specialists. At Fathom, you can imagine, it's actually a PM who does a lot of their prompt engineering. It was when I spoke to them last. But if you think about like a summary for a meeting, you want a different summary for a one-on-one than you want for a sales meeting, than you want for a planning session. And the engineer is not necessarily the person who's best placed to do this. So there's like one category of exceptional products where the engineer is, which is if you're building coding assistants. But for everybody else, you're going to need to like really heavily rely on domain experts. And I think that's often like underlooked how important they are. And whilst we're talking about teams as well, before I go on to talking about evaluation, another interesting thing that we've seen is early on, one thing larger companies are often trying to figure out is how do I get my company to sort of adopt AI or figure out to build things? How do I transform it and get people involved? And we've seen two approaches. One is sort of like more bottoms up, like I'm going to mandate that everybody builds something with AI, or like we have some AI feature in in every product over the next domain. And the other approach we've seen people centralizing a bit more. And it tends to be that the centralized efforts have higher impact and sort of avoid the, like what sometimes happens is you sort of see people like sprinkle AI everywhere. You see those little like magic star symbols appear, and there's like lots of incremental AI features, like, oh, now when you go to type a message, it sort of like populates the box for you. But no one has the central authority to say, like, actually, what things, if we change them in our product, would like meaningfully move the needle for customers. So an example of this was actually Gusto. So Gusto started with a decentralized effort and then eventually pulled everything into a central AI platform team. And then they built an agent called Gus that basically allows the accountants in the Gusto HR system to interact with it via an agent that can do what was hours of work for them automatically. And so the difference between sort of like having, I think their first product was like an auto CV generator for a job ad, which was like useful, but saved you a few minutes, versus eventually shipping an agent that now saves, hours of work for an accountant every time they interact with it. The impact you can have is much higher, but it required one centralized team who could have the overview of the whole product to be able to do that, and the authority as well. Okay, so chatting a little bit, next thing I want to chat about is the evaluation itself. So I'm going to talk about GitHub Copilot a lot because it's still my favorite of the OG LLM app that I think paved the way. And Alex Bravely is one of the co-creators of it. And I think this statement that he made like still stands true, which is in his opinion, baseline evaluation has to be the core of any AI application. And so evaluation, I think, matters at every stage of development, but it changes as you go. So when you're starting a new project, you're just beginning out, actually the first thing you're trying to check is just like, is it possible for the models to do this? And that's a moving target constantly. And so the first level tends to be very interactive. People are going into a notebook or a playground type environment. They're trying things out by hand. And as they're doing that, they're creating the evaluation criteria alongside, because as you do it, that's when you realize, oh, actually, I have this particular constraint that I need the model to satisfy. And so the spec or the evaluation sort of co-evolves in this initial stage of exploration, at the end of which you probably have like the first version of the system, and then people will run it over a mini data set, and they kind of get into the development stage. They'll run it over that mini data set, and they'll do an error analysis of like, what are the failure modes? And every error mode becomes an eval. And usually it becomes some form of binary eval, a sort of a pass-fail test. And this is one of the biggest differences between coding for LLMs or AI versus like traditional software. If you're coming as a traditional software engineer, you're probably used to being able to write deterministic unit and integration tests. And although this has been true in machine learning for a long time, for traditional software development, it's not the case that every time you run the program, you get a different result. And so just figuring out like, oh, actually what I need to do is not write a unit test, but I need to write an assertion against a data set. So when the model gets run over that data set, I need to know the accuracy stays above some percentage, or I need to know that some criteria sort of continues to be satisfied. And then once you move from development into production, evals don't stop. Like you still want to be able to monitor your production traffic, because you want to sort of understand the full generality of inputs that are coming in. How is that changing over time? So the same evals that you use in development, some of them will require ground truth, but a lot of them won't. And so if they don't require ground truth, you can actually run them as monitors. And so you can have a set of scores that evolve over time. And most of our customers now trigger an eval set like every time they make a major change. So if you're trying to upgrade the model, if you're making a particular change to a system prompt, this is kind of just like running tests in CI/CD. For a lot of our customers, it actually happens as a GitHub action, or a lot of people do it that way. and that then triggers an evaluation. The evaluation runs, and it comes back and it says, the scores they're never the same, but they're still like within the range that's acceptable or not. Why is evaluation for this stuff so hard? Well, one thing is that foundation models are just very general. And so the types of applications that they're applying to, they have a very long tail of inputs that might come in. If you're doing meeting summarization, the range of meetings that someone might chuck into your model or something like that is so broad that it's hard to sort of anticipate all the different ways in which someone might try to use your product. I've already mentioned the stochasticity. Every time you run this, you're getting different results. Then compared to traditional machine learning applications, it's often a lot more subjective. So, even in traditional ML, you have like accuracy, F1, precision, recall, blue scores. Like there are quantitative metrics of like how does this compare to the goal, like the ground truth. A lot of these more creative, subjective writing applications, things like that, there isn't one correct answer. And so you can't specify, this is the right answer to check against. And so that subjectivity makes it hard to necessarily score these things. And there's sort of a couple of ways around this. One is human labeling, and the other is trying to use the models as judge, and actually having some sort of scalable, the snake eats its own tail and the model scores itself. And I see someone in the audience smiling at me. So the reason why that's not crazy is that oftentimes there's a sort of gap between what the models can generate and what they can evaluate. And this has kind of been true throughout the history of machine learning. Generation is a harder task than evaluation. And so they'll often be very good classifiers of like, is this thing present? But they might not be able to write the answer correctly. And then sort of the subjectivity and the lack of well-defined metrics is similar. And then the last one I've put here is complex chains or agents. So if you imagine an agent that might have a multi-step interaction, in order to evaluate it and run it, you might actually have to mock steps that are coming from other systems. So if you imagine that you're evaluating an agent that will converse with your users, then when they ask the user a question, you need something that's going to come in to fill that step. And so there's sort of an infrastructure complexity as to how do I mock all of the systems that my agent might interact with. And also just like a combinatorial explosion of branching paths. And the way you can deal with that is by just sort of evaluating single turns. So you can break up the agent sort of trajectory and evaluate each turn independently rather than trying to evaluate the whole thing. I think that for a lot of subjective use cases, end user feedback is the most priceless eval you can get, but you only get it in production. But once you are in production, then GitHub Copilot, the way that they used to do this is they would measure like, was this suggestion accepted? Did the code stick around or stick around substantially, and for how long? And other applications, also gather it with these thumbs up, thumbs down. They gather actions. So did the user kind of proceed in the way that I expect? If I generated text for them, did they copy it? If I generated email, did they send it? But it's hard to get, and it's often, especially things like thumbs up, thumbs down, you're getting a biased sample from the people who care the most. So it's a useful monitor of how well things are working, but it's not perfect on its own. And so these are the kind of in-app, the types of feedback we tend to see people capturing. So sort of corrections, actions, and votes tend to be the main ones. But it's sort of necessary in practice to have some kind of scorecard of different evals during development that overall give you a picture of how well the system is working. And there's usually 3 types of eval. So and these kind of range from the cheapest being code, which is like closest to your unit tests. This is like, is it valid JSON? Is the length of my summary actually shorter than the thing I'm trying to summarize? Not an eval you tend to need anymore because the models have gotten smart, but was one that, a year and a half ago was not guaranteed. And then like, once you go past the code ones, when you're trying to include more subjective things like tone of voice or, even things like hallucination checking, like I have a retrieved context, I have the model's output. Does the model's output follow logically from the retrieved context? You can create a binary classifier for that. Most of the time, the way that people actually do this when they succeed is that they will create a data set, have a human expert, the most trusted expert, kind of do the eval, and provide critiques or explanations for like why they agree or disagree with the model's output. And then they'll use that to write the prompt for the LLM as judge. And they'll iterate this process until the LLM judge and the human have high correlation. And at that point, you sort of trust that the LLM judge is a good proxy, not a perfect proxy, but a cheap and scalable one compared to the human for doing evaluation. So actually where human evaluation ends up being used most, usually in my experience now, is to get the LLM evaluators tuned so that you can trust them. And then also people do it sort of on batches of samples. So they will take on some interval a batch of production logs and get them manually annotated as a kind of spot check of quality. And so the last thing I want to talk about is like the types of tooling that we've seen people be building and using to kind of get to success here, and what are some of the workflows that are different than before. So compared to traditional software development, there's a few things that have changed. One is you now have all these natural language artifacts, the prompts themselves, that are sitting around that are kind of somewhere between data and code. They're like configuration, right? They do have instructions in them. So in that sense, they feel like code, but they're really more like data. And for most applications, you want these things to be accessible to non-technical people. You want them to be able to iterate on them, but you also want to have the same rigor of versioning and tracking that you have for normal code. And so you need some solution for that. And we've seen a variety of different approaches, but that's one very common problem that comes up that you're going to want to think about. Another thing is like making sure that you have a good system for doing evaluation, both during prototyping, in development, and post-production. I think if there's one thing you remember, if you forget everything else I say, I think it's like if you don't build good evals at the start, like likely your project will fail. And the evals don't have to be super complicated. Like a lot of people are doing this with spreadsheets and having great success, right? So it's not necessary that this becomes complicated. I would only reach for complicated tools or more powerful tools if and when your simple spreadsheet methods aren't working or the simplest things to phase it stops to work. But you definitely need them. And then lastly, I think you definitely want comprehensive logging. So much of the there's so much that you gain from just looking at your data. And again, maybe this is something that if you come from a data science or a machine learning background is obvious, but if you come from a more traditional software engineering background, it's not necessarily the case that like just staring at logs is a super high value activity or not as high value. But actually just stepping through and looking at like what the model did, why did it succeed, why did it fail, in the cases that it went wrong, like why did it go wrong, that tends to be like an extremely high value activity that then feeds back into the sort of round of improvement and iteration. And so, there are different options for this. Obviously, like we're one of them, but there are open source tools. So Ironclad built this tool called Rivet that gives you a visual builder for this, and there's another one out there called Vellum that does that. And so there's a variety of tools, and I think that it is helpful to get some form of LLM ops platform in, but only if you've got the other things in place and you have them right. It's not a silver bullet. So that's like the end of the sort of concrete stuff that I had to say. I'm delighted to take questions, and we can sort of see where the conversation goes. But thank you so much.